Joe, how you doing?
I'm doing all right. Patrick, it's good to see you again, and good to see you virtually in this time of COVID.
It's all about upstream bandwidth. Yeah, so thanks again for being a part of this episode. I mean, just what we already talked about with platform, this is an enormous episode. And of course, we want to spend a lot of time talking about the new features that have been added into some of the module releases for network performance monitoring. And you actually have, I think, at one point or another, managed most of the modules in Orion. And right now, you're the product manager for NTA and VNQM.
That's right. That's right.
Yeah.
So this release, we are extending the breadth of visibility across multiple modules. We're delivering some key integrations that are going to make your life easier, and we've got a lot to cover. So we'll be talking about features here that help extend your visibility into your hybrid environment and do some hybrid management in your Azure network, surface some east-west traffic visibility down in your virtualized environment. We'll be able to handle edge device configuration a little bit more gracefully than we have in the past. We'll do some talk about some key integrations with IPAM and IP group management. We'll supercharge your device firmware updates, and we'll give you some additional visibility into some of your SD-WAN edge devices.
It's going to be a lot to cover, and this I think will probably be about the biggest segment because certainly we've got lots of customers that are using these products. What do you want to start with?
Well, let's get started with Azure Network Gateways. So Azure Network Gateways gives you some visibility between your network and your Azure environment. And this will monitor the VPN gateway and site-to-site bandwidth. This actually shares some configuration and some components with SAM and vMan. So let's take a look at how you get there. From the home menu here, we'll go to our cloud configuration. And what you'll notice is there's an additional widget here for gateway traffic by region. So in and out gateway traffic by region. The pull-out menu over here will take you to individual virtual network gateways or to site-to-site connections. If we click on the region, though, we'll go to a filtered view of our gateways. Let's take a look at what that looks like. So these are our Azure Network Gateways. You can filter those if you've got a long list of those by the account, the gateway type, location is already pre-selected here. The status or the virtual network that these guys are supporting. Selecting these individually will give you a perf stack integration, and I'll show you what that looks like. We'll click on one of these gateways here. That'll allow you to take a look at bandwidth in and out over time.
And I think the thing that's really driving that, right, is that when you move applications to cloud, and since hybrid is forever, you a lot of times you find out that an application that was fine on your LAN is actually pretty expensive to pull data out of, or maybe consuming a lot of resources. So is the goal here to really be able to just pull those in as alongside of all of your other bandwidth metrics?
Exactly. And so when you select all of your gateways, this will go ahead and populate all of those into perf stack, and you'll be able to do comparisons between those two. Lab environment, not fully populated, but you'll be able to see how you can stack those up against each other. One other way of looking at your Azure Network Gateways is by the individual VPNs. And so in this pull-out menu over here, you can select the individual VPNs. And again, there's some flexibility in terms of how you filter those by account, by encryption type, gateway, and so forth. And once again, with these, you'll be able to open these up in perf stack and look at these on a VPN by VPN basis and see the tunnel traffic that is specific to this particular VPN tunnel.
And then a lot of times customers are also monitoring the VPN specifics, maybe for an ASA or another appliance, where they can actually look to see what the real bandwidth is. And if there's a linking state error or something else, they'll drill down into that level of detail too.
It's a very similar presentation to what you've seen in some of our other VPN monitoring.
Okay, thanks, Joe. I mean, we hate to, admit it. We thought, well, I think some people thought hybrid was going to be for a little while, and the reality is it's going to be forever. And so one of those first big steps is gaining visibility into the cloud gateways, and this is really, really helpful. The second one, of course, is that you still have an awful lot of traffic that you're trying to monitor on-prem, especially in between hypervisors or individual VMs. So talk to us a little bit about VDS support in VMware.
Okay. The VMware Virtual Distributed Switch extends this kind of virtualized switching fabric across multiple hypervisors. And it gives you some insight into the conversations that are occurring between VMs that are hosted on each of these hypervisors. And so the Virtual Distributed Switch uses the IPFix flow format to report on these conversations. And depending on how you have it configured, those conversations will either show up as being all reported by the switch itself if you assign an IP address to the switch, or they'll show up as being reported by the hypervisor. And that'll give you some insight into what traffic is associated with each hypervisor. Now, in both cases, the traffic is actually coming from the virtual distributed switch. So let's take a look at what this actually looks like in NTA. So I'll navigate over here to my NTA summary. We're going to take a look at the sources of flow information. And you can see right off the bat, we've got a bunch of hypervisors here that are listed as sources. I'll show you another change for this release. In this release, we've actually separated out flow sources management to either show you a collection of interfaces or nodes. So we've really tried to reduce some of the clutter in this screen. Let's take a look at nodes, and we'll do a quick filter here to pull up a handful of hypervisors. You'll notice that these are listed as ESX servers, as sources of flow information. This is actually coming from the switch. But if we click on this, we'll be able to see traffic that's actually associated with VMs on each of these hypervisors.
And so it looks just like NetFlow from any other source.
Exactly. So it's very easy to find, very easy to navigate, and very easy to associate traffic with a particular hypervisor.
So you said something before that was interesting, which is you could choose to receive that either from the hypervisor, sort of the virtual switch level, or the individual application. And that's what's really interesting to me, because I can't tell you how many times I vMotion something, and then all of a sudden I run into unexpected bandwidth or maybe resource, or where the network really wasn't tuned for an application. I didn't know until I moved that workload. So is that really the goal there, to be able to monitor east-west regardless of where that VM happens to be?
Yeah, this gives you insight into application architectures. So what part of the applications are talking to each other? So if I pick up a VM and I move it across the data center, I'll have an understanding of what kinds of conversations I might pull across my physical switches. And likewise, if I want to pick up that particular VM and that workload and move that to public cloud, I'll be able to understand what kinds of conversations are associated with other workloads in that environment, and I might have to move as well.
Now, this does bring us to something else, which actually dovetails into a previous top ranked and voted up feature request, which is how do you keep track of multiple flows that may actually be on a single host where you're not double reporting that data?
Right. So let's roll into the next feature, which is node reconciliation. So in node reconciliation, we're basically providing you a mechanism to tell NTA when your edge router device configuration could result in situations where we are double counting traffic, and then we'll handle that more gracefully within the application. So for this, I'm going to point to a thwack posting that goes into some level of detail about node reconciliation, and I'll show you what this looks like. So you can find this on thwack in the NTA forum, and this goes in and provides some background on this challenge that we have with mixed configurations of edge router devices. And this has been a chronic problem, I think, based on how certain vendors permit you to configure the way that flows are exported. So to use this feature, we'll navigate to flow sources again, and we'll select one of our edge router devices You can see in the background here. And then we will bring up a dialog that says reconcile node. And in that dialog, we'll be able to specify on an interface by interface basis how we have configured the interfaces to export flow. So in some cases, we've got interfaces that may be exporting only ingress records or only egress records, some that are exporting both ingress and egress. And in situations where we have some interfaces configured to export flow in one direction and some in both directions, that can actually result in double counting the traffic as it transits through the node. So this feature allows you to reconcile NTA's view of the actual configuration, handle that correctly, and represent the traffic correctly.
So you're effectively giving it hints about what it should do with that data that's being collected.
Exactly. And then you'll be able to see accurate traffic volumes through the node as well as through the interface.
Well, I know that's been requested a long time, and hopefully we get some great feedback on how that's working. Okay, another big area comes when organization of traffic, especially where you're trying to map sort of the business's view of traffic to the actual underlying infrastructure. And I think we use IP groups for that, or a lot of customers are using IP groups for that. But there's been some extensions that actually make it a lot easier to manage in one place and tie it into IPAM.
That's right. So we've built a new integration with IPAM. It's been requested for quite some time that allows us to surface IPAM authored IP groups into NTA and use that. And so let me show you what that looks like. First, we'll navigate over to IP address management here. If I can find it, there we go, IP addresses, manage subnets and IP addresses. And one of the things you'll notice in IPAM is that there are organizations of subnets. We've structured these subnets together. Usually they either represent business groups, business units, or they represent geographies. And so users of IPAM take quite a bit of time to structure their subnets into something logical and understandable. What we'd like to be able to do is leverage that same kind of organization and grouping over in NTA without having to rebuild it from scratch. So let's see what that looks like in NTA. So we'll go over to our NTA summary. We'll take a look at the NTA NetFlow settings here. We'll navigate from NetFlow settings, and we'll look at where we manage IP address groups here. Now we've completely redesigned this page. We'll go ahead and dismiss that. And in this page, what you'll see is that you've got a collection of IP groups that are either managed by NTA or managed by IPAM. If they're managed by IPAM, you can't change them in NTA, but you can reference them, import them, and use them. And then that's pretty powerful. We've added a new feature here to import IPAM groups. And so you'll see the IPAM group structure that we looked at just a moment ago. And by selecting the groups that we want to manage, we will surface those in NTA. Now, you'll notice that IPAM's got a hierarchical structure. So we can import individual subnets over here, or we can import a single group that encompasses all of the subnets. So you'll notice if I click all of those, I'm going to get 5 groups here. And so I can work at different levels of granularity inside of NTA.
I was going to say, if you're configuring those groups inside of IPAM, then changing group membership will automatically be reflected in these groups as well, right?
Exactly. So as you make changes to those in IPAM, they'll automatically be reflected in NTA. Now, if you don't have IPAM and you're just creating IP address groups, we've also added a little bit of flexibility here in terms of how we define new groups in NTA. And so you can define those by using a range, which is a facility that we had before this, an individual address, or you can use the CIDR notation now. That has been a pet peeve of mine. We've added that. Makes life a lot easier for constructing groups in NTA alone. So let's see what we can do with these in NTA itself. So we're going to navigate over here, and we're going to start with the Flow Navigator. And so you're familiar with how to use the Flow Navigator. First off, we'll select a source of our flow information. So we'll look at a particular node here, and we'll select an application that we're interested in. So for flow alerts, we specify a particular application, and then we'll look at application volumes. So let's take a look at just our HTTPS traffic here. Now we'll go down and we can either specify an endpoint or an IP address group. So this is where we can start to use some of the groups that we have imported from IPAM. And so we'll add that to our filter, we'll submit that, and now we'll have a filtered view of traffic for the East Data Center IP group that is HTTPS traffic. So if I want to write a flow alert for that, one of the things you'll notice now when I go to create a flow alert is that I have a specification now for the IP address group that I've included. And that means I can write a much more specific flow alert that pertains to that group.
I just love that, because that is one of those things where, especially if you're doing, a little bit of social engineering, like you're trying to get people to watch their own consumption of maybe non-critical business bandwidth. But the problem is then if you write a lot of really specific alerts that are tied to IPs or hosts or something else or interfaces, you risk sort of spamming everybody. And so I guess the goal here is to reduce that, to make that specificity of alerting, to reduce the number of alerts that people can disregard.
Exactly. I can be very precise about the alert that I'm writing. So for example, if I want to look at traffic that falls off of a particular individual host and goes to 0, I can specify an individual endpoint here and then submit that. And when I go to create my alert definition, then I can use a form of the alert where I say my traffic now is less than or equal to 0, right? And I can detect a condition where traffic has fallen off completely from this individual node. Very, very precise kind of an alert.
I think this is going to be really helpful, and I'm really looking forward to all of the feedback from you on Thwack about how you're going to use this alert capability. And that between that and flow reconciliation, and then being able to really pull data from VMware switches, that I think is going to be really, really cool. So thanks for walking us through those. There were also a couple of really cool updates for NCM, especially in terms of being able to, deploy faster.
Yes, absolutely. Let's take a quick look at NCM. We'll look at network configuration here, and we'll look at our firmware upgrades. So we've made some changes to allow you to run multiple firmware upgrade jobs in parallel. We're not serializing those anymore, and that allows you to make better use of your very precious maintenance windows and keep your environment secure and up to date with the latest set of patches.
Now, of course, anytime I hear about parallelization, I want to make sure that I can control that. So you can actually do a hybrid, right? You can have some that are deployed all at the same time, but then maybe for a core or something else where there is actually a set of dependencies for the order that they need to be pushed out, you can still do that as well.
You can still do that. You'll need to structure those jobs, though. There's no dependency management yet, but you can structure those to do a batch in parallel and then do an additional job then that is dependent on those.
Oh, that's awesome. Okay, so that should result in faster deployments for firmware. All right, then the last thing is actually better visualization for branch office networks.
Yes, so this is a feature for the Viptela SD-WAN edge devices. And it's an integration with UDT to be able to visualize devices that are currently plugged in or the history of devices that have been plugged in to that device out at the branch, because it's not always convenient to walk to the wiring closet and see what's plugged in.
Well, Joe, thank you so much for walking us through these feature updates that are part of this release. And I mean, this is just for networking tools. One of the things that's interesting here is I saw a to me, a much snappier interface. So it looks like you were able to pick up a lot of the performance improvements in terms of how fast things render, whether they're updating in real time, the ease of use of a lot of the dialogues that have been updated. So that's one area where we're going to love to get some feedback from all of you, because these are the tools that you probably are spending most of your time in. And just in terms of configuration and like watching the IP group configuration, it'll be really great to get your feedback. So make sure you let us know on Thwack. And Joe, where can they reach you?
They can reach me at Reves on Thwack. And so that's probably the best way to message me directly. I would love to hear how you're using some of these features in your operational environment.
Awesome. Well, thanks again for being part of this segment.
You bet.